All right, so my name is Terrence Barkin. I'm the Executive Director of the Advanced Carbons Council. We are hosting today's session on the future of the carbon nanotube sector. And I'm really pleased to be joined by Dr. Alvin Orbeck-White, who is the founder and the CEO of a company called TrimTabs, who's a very interesting and emerging company in the carbon nanotube sector and is well versed in carbon nanotubes. We're going to start our presentation with an overview of the Advanced Carbons Council, who we are and what we do, and a brief overview on our view of the market. We have compiled recently a market report on carbon nanotubes, and I'll be sharing with you some highlights from that. So, as I mentioned, the Advanced Carbons Council is hosting today's webinar. I want to make the disclosures that any of the figures or information or data that you see today is not considered financial advice or should be used to make financial decisions. Those are just some standard disclaimers that we like to give, especially when we're talking about market conditions. The Advanced Carbons Council was launched just 2 months ago. We are already the largest and most trusted source of information across the advanced carbons community, building on more than a decade of working in the graphene sector, where we have more than 38,000 materials professionals in our global network that receive information from us, including regular newsletters that give updates on commercial news, patent filings, and research articles related to advanced carbons. Advanced carbons, for our definition, include 10 different divisions, including graphene, carbon nanotubes, carbon fiber, synthetic and engineered graphite, carbon-carbon composites, carbon nanofibers, etc., that you can see here. The reason why we've created the Advanced Carbons Council is because there's synergies between these materials. There are many cases, for example, where graphene is used in conjunction with carbon nanotubes, or for example, a graphene or a carbon nanotube might be used with carbon fibers to enhance those composites and matrices, etc. And so we also have companies that produce more than one allotrope of carbon. And so from that perspective, we think it makes a lot of sense to have these different material groups, which are quite disparate and often quite fragmented, together in one body so that we can be stronger together. Advanced carbons are able to solve some of our most pressing problems, including reducing embedded CO2 that's either directly through capture and then conversion into a usable solid carbon, or using these advanced carbons to reduce emissions in the first place. Water filtration, healthcare, renewable energy, these are all really important sectors that need advanced materials, because legacy materials cannot get done what we need done in any of these sectors. The world is looking for sustainable solutions across a really broad array of applications, and the beauty of these advanced carbons, and that would be carbon nanotubes along with its other cousins in the field, can be applied to so many different application areas. And one of the reasons is because of the attributes of this amazing material. Now, Rome wasn't built in a day, and the carbon nanotube sector certainly didn't emerge overnight, although lately it's had a surge of growth. But going all the way back to 1952, or almost 75 years ago, was really the origins of what we have today for the carbon nanotube sector. And today we've reached a milestone where we believe there's about 20,000 metric tons annually being consumed. That's both in sales, but also vertically integrated companies. In other words, the carbon nanotubes never see the market. They're used directly from production into an end-use product and internally consumed within companies that are vertically integrated. I'm not going to read all of these milestones, but it's just to say where we are today is built on many decades of hard work, research, and commercial development. Carbon nanotubes are made in a wide variety of methods, and these are listed here, each of them with advantages and drawbacks to them, or challenges, if you will. CVD method of production is one of the most common, and besides the methods of production here, which accounts for the wide, let's say, variety in types and forms of carbon nanotubes, you have a lot of post-production processing as well, with functionalization, filtration, refinement, etc. Carbon nanotubes are not one thing, but it's more of a family of materials. It's single-walled carbon nanotube, bi-wall carbon nanotube, multi-walled carbon nanotube of various lengths and various homogeneity. For example, you could have a mix of carbon nanotubes that are not of the same number of walls, nor of the same length, nor of the same stiffness, all within a mix of material that you receive as a carbon nanotube material. Carbon nanotubes are very exciting because of strength properties, electrical conductivity, and thermal conductivity, which explains why they can be used across a really wide spectrum of applications. In composites, they might be used primarily for their strength profile, and in another application for the electrical conductivity, and yet in another application for thermal conductivity as a heat dissipation material, for example. All of these are very common uses for the material today. So as I mentioned, single wall carbon nanotubes is one form, a multi-wall carbon nanotube, or specifically double wall, each have different structural properties, and they also have performance properties that lend themselves to different applications. And of course, with all of these nanomaterials, whether it's carbon nanotubes, graphene, or others, price is always a very important component of this. And we just recently actually had a very good presentation last week about the functionalization of nanocarbons. And it illustrated quite well that although, yes, these materials might have a high price tag on a per weight basis, oftentimes you need very small amounts of them to get the result that you need. And so the true cost is in the as used loaded factor and not the per weight factor. And in fact, the prices of these materials, because volumes have increased and production methods have become more efficient, prices have gotten to the point where they're quite competitive, and they should be considered as a standard industrial component, depending on what your application is. The major applications for carbon nanotubes at this time is in energy storage, specifically lithium-ion batteries. And I mentioned earlier how the different carbons can play nice together. We have seen examples where graphene combined with carbon nanotubes for battery active material is actually more effective than either of the materials on their own, depending on the mix and the ratio. Other applications are increasingly in electronics, and we see work moving beyond using silicon and using more carbon-based components for electronics, or even just for the very simple mechanical property of heat dissipation in electronic components, heat being the main factor in failure for electronic components and applications. And then, of course, the composites market, we continually see the pressing need to lightweight vehicles, either to reduce the CO2 for gasoline-powered vehicles, which remain a main component in the market, or the move to electric vehicles and the demand for lightweighting there. Also, in the aerospace market, one cannot ignore the fact that we now have globally a private commercial space market with thousands of satellites being launched and lightweight materials being absolutely critical for that. So there's going to be a continued demand for high performance, lightweight components, and carbon nanotubes certainly fit the bill for that. If we look at the patent landscape, and I know that Alvin will also cover this briefly in his presentation, but we did a review of patents. Now, this is just for the last 12 months. More than 4,000 patents related to carbon nanotubes have been filed worldwide. And the number one application is in energy storage, followed by plastics and polymers, chemical-related applications as an additive material, manufacturing, electronics, et cetera, that you see here. So as the Advanced Carbons Council, what we do is we do a comprehensive patent review at least annually. And then in our weekly newsletters, we also cover all of the new patents that would have been filed that previous week globally. And we do that on an ongoing basis. And we think that, following these patents, and we have a lot more detail related to who is filing these patents, who is receiving awards for these patents, and for which applications. This gives us a good indication. Companies do not go through the process of filing patents without an intent either to use it in commercial application, which we consider a proactive use of it, or they use it defensively. There are also companies that file patents to suppress innovation and to make sure that it doesn't see the light of day. So it's really intriguing to look at who's filing what patents for what purpose, and that's part of what we do at the Advanced Carbons Council. If we look at the market, and that was part of what we wanted to discuss today in our presentation, the largest market for carbon nanotubes is in energy storage, followed by electronics. The aerospace and automotive sectors primarily have to do with lightweighting and composites. And a very interesting one is in medical and biotechnology. And although we're not going to cover it in great detail today, one of the concerns about carbon nanotubes in the past has been, and this is true actually of any nanomaterial, is about the health and safety aspects of it. And this is one of the areas that we as the Advanced Carbons Council will be focused on, because most of the reference to health and safety regarding carbon nanotubes related to one specific type of form of carbon nanotube in the past in a particular study, and that doesn't adequately reflect the diversity of the carbon nanotubes that are produced, including the length and morphology of the primary particles, nor of the stiffness in the particles, all of which impact the level of toxicity and the way that you need to handle these materials. The good news for carbon nanotubes is, from the regulatory perspective, quite a few forms of this material have been approved in both major markets like Europe and the US through the EPA and TSCA. And so they are being used, and using just normal precautionary practices that you would have for any nanomaterial in a facility. They can be handled adequately without problem. So these are some of the major markets, and if we see going forward, we do anticipate that the main market for carbon nanotubes will remain in energy storage, but other application areas also will have some significant growth. So it's an exciting time with companies in the sector, of which we've recently reviewed, and there's about 125 active companies. So I'm going to pause my presentation here. I'm going to talk a little bit more about what we would like to do with the community of carbon nanotube companies, both those that are producing them, and there's actually a very large number of companies that are carbon nanotube companies, but they don't actually produce the carbon nanotubes. What they do is they acquire them and then further process them and put them in applications. And then also the customers of these materials. The Advanced Carbon Council does not represent just producers. We work with end users, we work with researchers, we work with producers, and we work with regulators, all of which have an objective of making these materials available on an industrial scale to be exploited. So I'm going to stop, and then Alvin, if you want to go ahead and share your screen, and then I'm going to put myself on mute, and it's going to be all your show.
Terence, thanks very much. I really appreciate that intro. I always love having the presentations from you. And I actually missed the one last week with the functionalization, so I'm actually going to go back and have a look at that later. So thank you again for the opportunity to present TrimTabs to you and your audience. As I said to you, I think the Advanced Carbon Council is going to play a really critical role in the future of carbon nanotechnology, and also with the other carbons, because it's great to have one consolidated voice for people to go and talk to, or for us to come and talk to as well, who's like an interested party and invested in all our futures. So as a quick background, TrimTabs is a term that was coined by Buckminster Fuller. I found it on his gravesite when I was at MIT, and it really inspired me as an idea that you make small changes to have big consequences. And I've always looked at carbon nanotubes as quite a wonderful material. It's got so many interesting properties. You touched on many of them today, and you had specific details of them there, Terence. But I think what I'd like to say here is that, like, if you think about the periodic table and all the various elements that are in the periodic table and the properties that they give us to give us the materials of the modern world, you can get a lot of those properties from carbon once the carbon is put into specific allotropes. And the allotrope of carbon nanotubes, you get very high conductivity, very high thermal conductivity, very high strength. You can be semiconducting, you can be conducting, you can be wide, you can be thin, you can be long, you can be short. And for all these different reasons, there's lots of avenues and applications of carbon nanotubes that we're consistently seeing growing, not just maintaining, but growing on a regular basis. And I'll point to that a little bit later. So I've always been exhilarated by carbon nanotubes. I hope you can tell that as well. And so I really wanted to get into a way of making carbon nanotubes that would be in a sustainable fashion. So I approached this from the chemical vapor deposition methodology that you mentioned earlier. It's one of the most common used industrial processes. It's most easily known and developed and scaled up, because you need to do things at scale. Unit costs have to come down, and configurability in the production has to go up. And what we found is you can actually utilize waste materials such as plastics as carbon feedstock. It's actually quite advantageous to use some plastics. They increase the yield of the production, and in some cases they also confer some additional properties onto the carbon nanotubes, like they can help register the types of diameters that we're getting, and we can also put in other interstitial materials like nitrogen into the carbon nanotubes, so we can make carbon nitride nanotubes in a one-off process. In our production facility, we'll have the capability of rerouting the off gases. This is not something we're doing now, but it's something we're planning to do, and also capture hydrogen. And we've got a list of the different carbon nanotube products that you can get access to. You can use that QR code, or you can just go to our website and you can go and look at the materials that we have that we are creating. What we've also done is made this in a way that is a little bit more modular, and we scale in that way, as opposed to making a big factory in a production facility. We make much smaller production units, so they can be more modular, so they can be localized wherever manufacturing is necessary, onshored manufacturing is necessary. We think that's the way of the future, and that's the way that we're providing our technology. When we look at the utilization of waste materials, we see a number of avenues of impact in terms of environmental impact and also economic impact. If we were to turn or divert waste solvents and plastics and turn them into nanotubes to make wires or batteries and use them in the grid to save energy, we could save multiple kilos and even tons of carbon nanotubes. So for example, in one of our units, we could turn in a year 250 kilos of waste plastic into a product we could sell on the wholesale market for approximately £250,000. So that's definitely waste to wealth. There's also avenues for capturing CO2, again in our recirculation process. And if, for example, all the batteries ever made were consumed using carbon nanotubes via our process, we'd be saving a lot of plastic from going out to landfill. So this is part of the reason why we formed TrimTabs, to do it this way, because we wanted to stop waste carbon from ending up in landfill and from ending up in our diets. But we also wanted to make high quality, high class distinguished materials for bespoke applications. One of the bespoke applications we're really focused on is wires and wiring. And we're going to be working on that now in the next few years to really expand that potential and capability. You mentioned as well patents. I think it's really interesting that we're both doing the same thing, because we're looking for what other people are interested in, what they are doing. I've broken this down in terms of patents based on applicants, because again, I look at this as a potential to see what type of avenues there are for consumers or for producers as we are, to see how people are consuming carbon nanotubes, both from a defensive perspective or from maybe an offensive perspective, where they have actual derived applications for their nanotubes. And you can kind of get a good view from the outside, even if you have vertically integrated technologies or vertically integrated industrial giants. You can kind of get an idea maybe from the outside of where they're using and how they're using their carbon nanotubes. So it's been interesting from my perspective to see how many patents are being created. As you said, 4,333 is just a massive amount in the last 12 months. And you can see there are patents that are not granted yet, where they're going, who are patenting them, who are filing them. Obviously, when you file a patent, you try to ring fence your technology, but you also introduce a little bit of risk. So you have to take an understanding of take maybe a pinch of salt as to the seriousness of all these patents. But it's been really interesting so far to see and to watch this space, how it's trending, and to notice that actually there's a lot more patents being filed now than have been filed in the last, I'd say, 4 or 5 years. When we started, obviously one of the first things people would ask us is who's buying your nanotubes, and what is the sentiment for the purchasing sentiment. So we contracted Isaac Frank, there's their name down the bottom, to do a marketing survey for us. And they reported on this in August of last year. So maybe the timing is a little bit off, but I think maybe the sentiment is the same. What we basically found is a lot less green. Green is satisfied or very satisfied. There's basically a lot less green than we had thought there would be. There's more people out here that are consuming nanotubes that are really not that happy with the kind of nanotubes that they can get. It's either because of the time frames or the cost or the deliverability or the offerings, for example. So we've really seen this as an opportunity for a new player as ourselves to break into this market and to try and talk to these people and understand what their needs are, and then provide nanotubes for them, again, using the more bespoke modular framework that we've developed at TrimTabs. Now, a year ago, had I given this presentation, everything would have been gangbusters on electric vehicles. Carbon nanotubes go into batteries, they go into electric vehicles, lithium ion, you mentioned earlier. Things have changed. They're still being, lithium ion batteries are still being produced, they're still being made, carbon nanotubes are still utilized in them, but there is a lot more cottage industry, so to speak, around that area because there's a policy tailwind supporting it. That's changed. But what hasn't changed is the demand for carbon nanotubes, so to speak. There's still a large array of carbon nanotube applications, and we're reporting on them ourselves on our own website on a consistent basis whenever we see new interesting stories about where carbon nanotubes are going, both from a research perspective, but mainly from a market-driven perspective when companies are producing or reporting on their nanotube applications. And we're seeing applications, for example, data centers, quantum computing, AI chips, and Dow and Carbice. Congratulations to them. Done this great deal about, Carbice is this technology for thermal cooling of silicon chips, and that's obviously a big thing in the AI data center space. So we're seeing a lot of these applications on the rise compared to the traditional thinking of the last 4 or 5 years, where the nanotubes are going to be utilized in predominantly lithium-ion batteries. And I think now is really the best time for an organization like the Advanced Carbon Council, because when we have these tailwinds coming up, you need an organization that you can get behind to talk to and rally the troops and understand what the sector looks like. And I think what's critical, and I've heard this from many other commentaries in this space, is that we need some form of identification or metricization of our nanotubes, because as we said earlier, you can have long, short, thin. They all have different applications and they all have different use cases. And so no two nanotubes or no two nanotube providers are going to be the same. And when laws are made, they're made using the English language, and then they have to be refined. And we want to make sure that we don't get pigeonholed into one scenario, unfortunately. So I really think it's critical what you're doing here, Terence, at the Advanced Carbon Council to work this forward so that we can see more growth like this. And, if I come back in a year's time, I think the stories here are just going to continue to grow. So thank you very much. On the left-hand side, you can see QR codes if you want to get in touch with us, see our nanotube newsletter, or have a look at what our products are. And I'd love to answer any more questions in the Q&A.
Excellent, Elvin. Thank you so much for that. And if you do have questions for Elvin or for myself, use the Q&A dialog box. I am going to continue just with a very short additional part of my presentation, and then we'll go to Q&A. So just to outline all of the things that the Advanced Carbon Council can and is doing, and what we would like to do with the carbon nanotube community. We produce regular information. Everything is fact-based. Everything is science-based. No fluff, no hype. We're trying to be quite sober about this. We have networking opportunities with an in-person meeting. I'll tell you a little bit more about that coming up, but we're going to be in Birmingham, UK at the Advanced Materials Show, and we're going to have a dedicated Advanced Carbon Council meeting, including a really nice networking opportunity. We're going to have a 2-hour open bar, food and drink networking session for you to meet each other and also to meet with other colleagues in adjacent industries. We are a membership-based organization. It is a trade association. We are globally based. We're incorporated in the US, in the UK, in Manchester, and in Switzerland to deal with the different geographies around the world. We actually offer material testing, characterization, and verification services so we can deeply characterize the material and then provide a technical data sheet and a safety data sheet for your materials. We work on standards. This is a form of education outreach that we have today to help educate and inform people about these materials. And we've also worked with investment groups on technical due diligence projects as well as advocacy. We work closely with regulatory bodies, and I can tell you from our discussions with regulators in the United States, they are seeing more and more applications for the use of carbon nanotubes, and we have a very good dialogue with them about the standards that are needed, which I'll talk to you about in just a moment. So this is my ask. We would really encourage, if you're active in the carbon nanotube sector, either as a consumer or a producer or an intermediary company that uses these materials, we invite you to consider joining the Advanced Carbons Council for industry insights, the networking, advocacy, anything that you might need from A to Z. We're here to help you. And the goal at the end of the day is to help advance your business. Specifically, there is an ISO technical document called Nanotechnologies Characterization of Multi-Wall Carbon Nanotubes. So this is an ISO standard that is out there and is up for revision. In addition to this, we also would like to identify if there are gaps in the standards that exist, either in carbon nanomaterial nomenclature, which is another document also under review. The Advanced Carbons Council is a member of the TC229. This is the Nanotechnologies Technical Committee within ANSI ISO, and we're also present through BSI and other standards bodies. Wherever you're located, if you have an interest in this, we encourage you to reach out to us to talk about how to get engaged in this technical work. We have successfully in the graphene sector created a document called the Graphene Classification Framework, which we then submitted through ISO, in which has become a technical standard that is being published at this time. So we would like to do the same with the carbon nanotube sector to make sure that the interest of both the consumers and the producers of these materials are represented in the standards that are developed. And if you're not in the room to help set the standards, then you're not going to be able to influence them. And that's what we can do for you and with you as part of this technical task force. We've also issued the carbon nanotube report, which over the last number of months has been constructed. And we took the time to verify the companies that were actually producing or using carbon nanotubes. There's more than 125 companies that are profiled and part of this, as well as discussions in more detail on the patent landscape, as well as production methodology and all the different applications for carbon nanotubes. This report is available for purchase separately, but we include this as a benefit of membership in the Advanced Carbons Council. And as I mentioned, we will have an event in Birmingham, UK, 8 to 10 July. It's a fantastic opportunity for networking and to connect with potential clients and consumers of these materials. And we do have a dedicated program of content over these 3 days. If you're interested in making presentations or speaking, that's something else I would love to have you talk to us about. And so for any information related to any of the advanced carbons, including, of course, carbon nanotubes, please reach out to us. There's some contact information. And with that, Alvin, I'm going to stop sharing my screen. And then we should just go ahead and take some questions. And if anybody does have questions for either of us about anything that you've seen or about carbon nanotubes in general, now would be the time to ask your questions. So if I look at this, first of all, for Alvin, it says, curious if the plastic waste streams that were displayed all require their own processing routes, or can you combine them all? So for the feedstock that you're using, which by the way, I think, obviously is an interesting use, is taking waste plastics out of landfills and making them into a usable, valuable product is quite good. So what does that look like for you in terms of the supply chain for your raw material?
Yeah, this is a great question. So I want to clarify, we wouldn't really be taking plastics from landfill. Our thesis really would be that we would divert plastics from going to landfill, so we'd get them from a clean source as much as possible. For example, a lot of people will have factory offcuts of little pieces of plastic, polystyrene or polyester, or maybe mixed plastics. And if it's a clean, generally clean, but it's a mixed plastic, it can't go in the recycling route. It could potentially go through our processing, and we could utilize that. So to the first question about the different types of plastics, the basic tenet of chemical engineering is the product that you get out depends on the material that you put in. So there can be fluctuations or alterations made to the product that you get out as a consequence of the material input that you put in. So it's not a simple answer to say, yeah, we could use lots of different plastics. We'd have to do maybe a bit of science on that, but we've done quite a bit of science already, and we're just in the engineering phase of scale up and production. So there's more science to be done to understand the large variety of plastics and combinations, permutations you can imagine of different plastics. But we're kind of past that now, where we focused on certain plastics and working more towards the engineering and production. Still have a scientific mind to look at other opportunities. So if people come to us with other opportunities, we'll still look at them and have discussions. Come reach out. And then on the other point, or let me say one more thing about I see it about can you combine them all. One interesting thing that we have done is, for example, this was at low TRL level now. This was at the laboratory scale, but we once we've seen it at the laboratory scale, we've got our system we can scale up. Is we took, for example, an ostomy bag, which is a bag that gets situated on the side of a person's body and collects effluent from them. That's a composite material, sometimes 12, 15 different layers, sometimes 10 or 20 different types of plastic. So that's almost the worst case scenario for a recycling sector. We could take one of them bags and just use that whole bag to make carbon nanotubes. So we did it. That took a lot of science to work out how to do that, but that's something that we could do. So to answer that question, there is potential that a lot of things could be mixed together to be made into nanotubes. Reach out. Let's have a chat.
Excellent. There's a question here, and it looks familiar to me. It's talking about tuning the process to achieve specific characteristics, and can you work with potential customers on their individual requirements? I'll give one comment, and then Alvin, I'd like to hear your response on that. One of the things that we've observed over the past with nanomaterials, and Alvin, I'd be curious if you've had the same experience, is that, a lot of times customers say, well, give me a sample, let me play with it. I'd like to work with it in my application or whatever the case might be. And then, unsurprisingly, they'll come back and say, well, it didn't work. And our experience has been, when dealing with nanomaterials, dispersion is really important. The surface chemistry is really important, how to get it to interact with the matrix and stuff. So it's really critical to have a partner that can help the customer, tune to the particular application and get out of it what they need. And we don't really, what's the disclaimer? Don't try this at home. We don't suggest people just take these materials and play with them when they don't maybe fully understand some of the intricacies of it. Can you talk a little bit about that, how to work with customers for their particular application?
Yeah, absolutely. I'm going to reshare one of my slides if you don't mind, please, because I think it
Sure.
helps elaborate this. So when we created the questionnaire for this survey, one of the questions I was adamant about that we put in is this one here. That the question was, are you satisfied with your carbon nanotube supplier in their ability to help you improve your offerings? So if you're making thermal materials or you're making batteries, are you happy that the carbon nanotube provider really helps you expand your potential and your capacity? A lot of people here, there's some satisfied, but there's definitely nobody very satisfied. And that was very illuminating to me. The guy said to me that I think it's a similar question here. Can you work with people who have individual requirements? Yes, at our scale, we could work with a lot of people who have individual requirements. Not that we will always be able to deliver what you require, but we will definitely talk to you and work on what it is that you need. And if we can deliver it, we will. What we have seen is, from our conversations, what I've learned is that people are generally used to and expect that when they buy carbon nanotubes, it's kind of a one size fits all. It's like when you get a baseball cap, it's just like one size fits all. But everybody that we're talking to has got very unique requirements, whether it's photolithography or whether it's silicon chips or it's lithium ion batteries or lithium sulfur batteries. They don't want to buy they don't the same nanotubes as everybody else because they have different requirements. And so we see an opportunity in that space. And like I said with my earlier answer about using the different plastics, because the plastics can confer slight changes on the carbon nanotubes, we have the ability to match those two worlds where we can take the different plastics and make different nanotubes. That could be advantage of somebody. So absolutely reach out, let's talk. No guarantee that we can absolutely supply to you, but we would love to work with you.
Excellent. Now, we encourage people to work with partners who can help them on their specific application rather
Yeah.
than just ship them a bag of material. There's some technical questions regarding, the surface area of your multi-wall carbon nanotubes, which is of interest, but it's very specific. And then also on the amount of in-process hydrogen generation that comes out. That could be interesting. We do see a lot of hydrogen production coming on stream,
Mhm.
and what many of these hydrogen producers are realizing is they're producing many different forms of solid carbon as
Yeah.
byproducts.
Yeah.
That's another area that we are looking at, is to kind of get our hands around all these different allotropes of carbon and what to do with them in a very constructive and positive way. So talk to us just a little bit technically about your process regarding hydrogen production and the morphology of the material that you have.
Right, so I'll start with the hydrogen production. You're starting with a hydrocarbon, you're solidifying the carbon, you're liberating the hydrogen. The quantities of hydrogen we're going to be liberating would be enough eventually to either recirculate and reutilize because it's part of the input. It's not a feedstock, but it feeds the catalyst production process. And if you're familiar with chemical vapor deposition, you'd know to expect that. There is a pipe we've works. We've filed patents or provisional patents for collecting collecting the hydrogen, because we calculate and expect to be collecting quite a lot of hydrogen at certain capacity levels. So it's kind of like a tiered capacity level where a certain production level, then it justifies the quantity of hydrogen that you're going to produce that you'd want to actually consume it or capture it. So it's different tiered levels. So that the answer to that question is it could be fully reused or it could be captured and be an energy vector in some other source and some other place. And we're in discussions with where that energy vector could go. Again, with the idea of the modularized production is that if somebody else needs hydrogen, then this is somewhere that we could co-locate with other people because our micro factories are not massive. On the question then about the morphology of our materials, there's a wide variety of morphology that we've made over time. Again, because to that other question about working with different customers, we try to work with customers as much as possible. I will say that we're focusing on wire and electronic technology, so we're focusing our gearing towards that a great deal. But we're definitely keen to understand what everybody else would need, and then if we have materials for them, or it's very easy for us to make materials and we can see a pathway, then we'll work towards that. So the variety of properties that we have is presently listed on our website. You can see, actually, Terence, you mentioned the reports that you've done. Like we went, unbeknownst to me, I went through that process where we had a third party lab look at our material from our early days. So we've grown since then, and we've developed our technology since then. So things have changed, and we're gathering more data about our material properties. And if there's anything specific that you need, again, just come and have a chat. Maybe we have it on our shelf ready to go, or it's right around the corner.
Excellent. So one of the other questions comes up is about quality control and how to maintain quality control. The comment that TEM TEM testing is not cheap. That is true. I will say the Advanced Carbons Council does provide material testing and characterization services. We've also run a verified producer program where we actually physically inspect production facilities. We take a sample of material, we verify capacity claims, and that sort of thing in order especially for large, sophisticated supply chains. If you're going into aerospace or automotive, they demand some transparency into the supply chain, and we can provide that expert third-party validation for them through the testing and characterization. Can you talk a little bit, Alvin, about the quality control process that you guys might use? And then another question related to that, maybe you take that at the same time, is just asking about the capacity of your modular units in terms of volume.
Right. So quality control is critical because if you're going to use a nanotube in a certain application and you want to go buy the nanotube again, you want it to be the same. You don't want to have the variance in the production. So in our journey so far, we're not a consistent supplier of material because we're working towards a specific goal that we're working on. But how we do that is through a very structured and rigid, not rigid, but very structured operations, operations dynamic. So we have the capability to stay on a certain type of material and continue to focus on making that material on a repetitive basis, but we're still working a bit on the exploratory phase of working towards more idealized structures. Excellent. So then to go back to that, maybe starts to answer the question about capacity. We have a system now that has got capacity for several tons, but we've got a design in play that we're working towards. Our version 2, which would be going somewhere towards 60 and 72 tons per modular factory.
Excellent. Well, I think, Alvin, at this point, we can kind of wrap up our session today. We've had great questions from the audience, and I really appreciate everyone's attention. From the Advanced Carbons Council, we certainly encourage you to engage with us if you have any questions, if you're active in this sector. We act as an independent, neutral party to help facilitate networking, interactions, and the advancement of your businesses. We're really proud to have TrimTabs as one of our members in the Advanced Carbons Council and work together with Alvin and his team as we work in this very exciting sector. And Alvin, I'll just ask you if you have any closing comments before we close today's webinar.
Real quick, I mean, being a member here has been great. I'm just, I'm going to big up your own report. I've bought several market reports over the last few years, growing TrimTabs, to understand what the market is like. And I think your market report is one of the best that I've read. I'm not just saying that because I'm on this forum, but like genuinely, it's got all the things you're going to need about carbon nanotubes. And if you continue to do that on a regular basis, it's going to be the must read, I think.
Well, thank you, Alvin. And we wish you success with your journey through TrimTabs. Thank you, everyone, for paying attention. Have a great day.
Yeah, see you. Bye.
Take care.